I'm Brian Mann, and you're watching the third episode of Backbone Rails. Marionette, as we introduced in episode 2, is a framework that sits on top of Backbone. It was originally created in December 2011 by Derek Bailey, who is a prolific Backbone developer, blogger, and seasoned JavaScript veteran. Marionette has its own dedicated website here, and of course its own GitHub repo with all of its documentation, wikis, examples, and tutorials. Marionette has been forged from being used in many different types of applications, which means it's not built specifically for one workflow or application type. It's built to be modular, so you can mold the various components to fit your application's needs. Marionette brings a lot to the table, and it's typical for beginners to have a difficult time understanding how they can wield each of its parts. You have a lot at your disposal, so throughout this episode, and really for the rest of Backbone Rails, I'll be going over each piece in detail, adding layer upon layer and showing you how each works in conjunction with the next. If you stick with it, soon you'll understand how to coordinate these pieces by yourself, which opens the gates for building amazingly powerful applications. So let's get right to it and revisit the feature we just built in Backbone in the previous episode. Remember, we had a simple scenario here where we wanted to fetch a list of users from the server and insert them as rows into a table. Let's jump back into our Backbone view, which I previously described as a collection view. And remember, while all Backbone views are the same, Marionette has specialized view types. So instead of inheriting from a vanilla Backbone view, we'll need to inherit from a Marionette view. Looking at our diagram, we have quite a lot of different views to choose from, so which one should we work off of? One of the best aspects of Marionette is how well documented it is. If we hop back over to its GitHub repo, we can see exactly the difference in responsibilities between each of these view types. You can read about each in detail, and almost every day I find myself referencing back to these docs to remember the name of a method or to look up the details of when a particular event happens. Nevertheless, I'll cover the differences in responsibilities here. There are 4 primary Marionette view types. An item view is a view which assumes responsibility to a single item, usually to one Backbone model, but it can also be used on collections as well. Item views have no special automated built-in behavior, which makes them the most primitive view type. A collection view has the responsibility of managing an entire collection. It's wired up to automatically iterate through each of the models within its collection, while creating and managing new views for each of those models. Interestingly enough, typically a collection view usually creates item views for each model, but not necessarily. When you start building more complex features, you might have collections nested within other collections. For times like those, you could easily create a cascading effect where the first collection view creates a secondary nested collection view, and then that secondary nested collection view iterates through and then creates item views. And you'll see us do exactly that in later episodes. A composite view is identical to a collection view, with the difference being that it always has a template, whereas a collection view cannot have a template. The qualifier for deciding when to use one or the other is basically how you'd like the item views to be inserted. In, say, a normal unordered list, you'd want a parent UL with children LIs. In this case, you'd use a collection view because you don't need a wrapper template. You'd set the collection view's tag name to be the UL and each item view's tag name to be an LI. In a separate scenario, say you have a tree list view. You'd want to organize children within a parent category. So to do this, you need a wrapping template around the children to set up the initial structure, and then insert the child views somewhere directly inside the parent's template. And in this case, you need a template and thus a composite view. As you get more experience with Marionette, there are other nuances related to choosing between these views, which we'll cover when we develop our full stack application. Finally, layouts add a totally new piece to the puzzle. They are actually item views, but they have one enormous difference. Layouts have the responsibility of managing regions within themselves. All layouts have a template, and inside that template you can declare regions which are paired up with DOM elements via a jQuery selector, meaning a layout is like a frame, a holder, by which you can then insert other views into those regions you've configured. This way we create a hierarchical structure, determining where and how other views are inserted. By tying all of our views together, we create an elegant Russian doll configuration where bigger views are containing smaller views. That means whenever a layout is closed, it'll automatically cascade and close all the views within its regions. Layouts for me were one of the first big revelations I had, where once I understood them, I immediately saw how I could slice all of my views in whatever manner was necessary for virtually any feature, and cleanup would happen in a very natural way. So far, we've covered a high-level overview of each view's responsibilities, which is a great starting place for deciding which view you need. I should note, though, that there are considerably more differences between each, and little by little we'll start to reveal those differences. So coming back to our backbone view, it's pretty obvious which Marionette view we need to extend from. Since we need a template, and we need to decide where our item views are inserted, we'll use a composite view. If you don't remember, this is the actual HTML our template is rendering. So with our composite view in place, we can now begin to clean up the backbone boilerplate. As per the documentation found on Marionette's GitHub site, when this composite view is rendered, Marionette will automatically iterate through our past in collection, creating new views for each model in that collection. So we no longer need three things. Composite views and collections are automatically wired up to the reset event on our collection, so we can remove our initialize method. Interesting as well is that our composite view is also automatically wired up to the add and remove events on the collection. It's intelligent enough to handle this automatically, meaning that if a model is added or a model is removed from our collection, it'll automatically add or remove the equivalent item view. It does this automatically, which means we can also remove our add one and add all methods. So all we need to do here is tell Marionette two things: what views it should create, and where in the DOM these new views should go. To do that, we reference another view with the item view property. Though to be clear, as I previously mentioned, even though this property is called item view, you can actually pass any view type here. It doesn't actually have to be a view, which is an item view. It could be a reference to a collection view, a composite view, or even a layout for that matter. Now, we need to tell this composite view where these views should go. So to do that, we set the item view container property, and we just pass it in a string, which should be a valid jQuery selector. In our case, it's just the tbody, and there's only one in the template, so that's all we need to pass. It's just the tbody element. Now, if you were watching closely, you might think, in our old code, we also had to decide how these new views would be attached to the DOM. And rightfully so. We said that each of these views should append into the tbody, so each view naturally adds to the next. We don't have to tell our composite view to append these because it naturally already uses the append method. However, if you want more control, you can still override this behavior if you needed them to be attached in another way, or even in a certain position in the DOM. To do this, you would override the append HTML method, and you can just check the documentation to see exactly how that works. So wow, we've cleaned up quite a bit so far, but we also no longer need an explicit render method. All of Marionette's views automatically come with the default render method, which we'll get into more details later on. All of Marionette's views come with a common set of events that are fired throughout their lifetime, and each view also gets events specialized for its particular responsibilities. Since our composite view has the responsibilities of managing its collection and the associated views it creates, it'll also fire special events as that chain happens. These special events are on before item added, or on after item added, on item removed, and each of these pass the item view as an argument. This gives us the ability to hook in and execute code or implement some functionality according to when these events happen. And one last really important note about composite views and collection views is because they are naturally managing and creating other views, similar to the way that layouts work, if they are closed, they will automatically close all of the views that they're managing. So when we're ready to navigate away to a different page, we just have to ensure that this top level composite view is closed, and it'll naturally close down the rest of its item views. We haven't exhaustively covered every aspect of a composite view, but let's recap what we've done so far. Composite views take a template, and that template's rendered into the DOM. When the reset event was triggered by our collection, our composite view automatically iterated on those models, creating new views based on the item view property and inserted them according to the item view container property. Another note here, and one of the unsung heroes of collection and composite views, is that they both take an optional empty view property. This empty view references a separate view altogether, which would naturally have a different template. And this empty view would automatically render instead of the item views if the collection has 0 models in it. In other words, instead of just rendering nothing into our table and it having 0 rows and looking broken, we can instead insert a row that has a different template and styling that says something like "No users found." Composite and collection views are also automatically wired up to these events and handle them appropriately. And finally, they also emit and fire special events because of their unique responsibilities. With composite views out of the way, let's jump into the item views this composite view was creating. So this is what we did with our old plain backbone view. Let's go ahead and remove the old backbone view and extend it from marionette.itemView. Naturally, item view here is a perfect fit because these views will only have one responsibility to one model. And since these were created and they're being managed by our parent composite view, we can immediately remove the render method, as this is implemented by Marionette by default and it's automatically called by our composite view. If we take a quick peek into our template, we notice nothing here has changed. Our template still has access to the properties on our model. And in this case, a model was passed to the item view, and thus Marionette, as part of the render implementation, automatically calls to JSON on that model, and which makes these properties available to us in our template. Since we still want to be able to click the anchor with the class of destroy, which will end up removing our model, we still need to manage this event. And so after capturing that click event, we still need to destroy our model. However, we can remove this binding to the destroy event because when our model is destroyed, it'll automatically cause the remove event to be fired on our parent collection. And because our composite view is automatically wired up to the remove event, it's smart enough to automatically cause this item view to close, clean up all the bindings it had, and remove it from the DOM. So therefore, we can also remove this implementation. Like our composite view, item views emit events throughout their lifecycle as well. This gives us a convenient way of implementing some type of behavior as the view comes into existence and then eventually closes. So here are the most common events you'll be working with. So to recap our item view, They're responsible for one item, either a collection or a model. They're automatically rendered, so we don't have to provide our own implementation for how they're inserted into the DOM. They fire a lot of different events, which we can tap into if we need to handle those events in a specific way. You'll end up doing this on a regular basis in a real application. A few things we didn't cover, but definitely worth mentioning. You can cache the DOM elements within your item view, so there's not a performance penalty every time you need to operate on one of those. And when you need to bind item views to specific model events or collection events, you have an easily configurable way to do that, which Marionette provides for you. At last, we have finally made it through this feature. And in doing so, this is what we've accomplished. We had our composite view set up the initial HTML structure for us within its template. When the collections reset event fired, it automatically created new item view instances for each model and rendered those into the T-body. Our item views were wired up to listen to the click event happening on the anchor with the destroy class. Upon that event firing, our item view would have destroyed the model, the remove event would have bubbled up to our composite view, and that would have automatically removed this item view from the DOM. You would have seen it disappear, as you'd expect. So we've covered a lot of ground already. And to be honest, most tutorial series would probably stop at this point with closing out a feature. But if we take a step back, what have we really accomplished? You might have a better understanding of working with a few Marionette views, but we haven't even stepped into the arena of composing and orchestrating the many features that make up a real application. We haven't tackled any of those other important aspects like how we even navigated to this page, or how we navigate away from it. In episode 4, we'll factor what we've been building into a more complete application set. We'll walk through each of the other structural components of Marionette using real production code you'd see working with Backbone every day. I'll be going line by line, giving you insight into how each of these components works off of one another. Episode 4 will be the last episode that's fully animated. And after its completion, we'll jump straight into using a real browser and beginning to build our application with all the layers we've just covered. The pace from here on out will pick up considerably, but if you stick with it, you'll see a lot of great repeatable patterns and conventions you'll soon be familiar with and comfortable using.